Imagine a class with a house. In a house, there are many different rooms with many different purposes, such as a kitchen, a bathroom, or a bedroom. These are the equivalent of methods within a class. There are many different methods with many different purposes in each class. Now, in a room, you would have a door from the inside to access the room. In the same way, you would have a way of accessing the method from within the class. As you can see with these rooms, there is no way to access these rooms from the outside. In the same way, a private method cannot be accessed from outside of the class. Public methods are very similar to private methods. They can be accessed from within the class, just like in a private method. However, they can also be accessed from outside of the class. This, in our scenario with the doors, is like having an entrance from outside of the house into one of the rooms. As you can imagine, this wouldn't be very safe because it means anybody can come into any of the rooms and mess with the stuff inside the rooms. In the same way, a public method can be unsafe because it could be used in ways it was not intended to be used. Fields are like objects within your house, such as a stove or a table and chair. These are the type of objects that are in your house and you wouldn't let just anybody use. However, objects that are outside your house, such as a potted plant or a garbage bin, these are the type of objects that you don't value as much, and it's okay to leave them outside your house because nobody will mess with. In the same way, these are public fields and these are private fields. The private fields are sensitive and valuable and you don't want people to mess with them. Public fields, you wouldn't mind if anything happened to them. We now need a main way of entering this house, such as a main entrance, which is equivalent to a main method within the class. If a stranger were to enter your house, you would probably accompany them since you do not trust them with the things inside your house. If they wanted to, let's say, sit in this chair, you can either allow them to sit in the chair, which would be a mutator method, and you can give them restrictions such as you can only sit in the chair, you can't jump on the chair or something like that. Or you can say, no, you can only look at it, which is the equivalent of an accessor method.
The program we will be using for this topic is the rectangle program. The instance fields of the rectangle class is double left and double bottom. So these two are the coordinates of the bottom left edge of the rectangle. Double width is the width of the rectangle, and double height is basically the height of the rectangle. We have built two constructors for this class, public rectangle, one with 4 parameters, which are left, bottom, width, and height. So users can change the values of these instances by inputting the values to the parameters. And then there's the default constructor. We just gave default values of the instances. So the coordinates of the bottom left edge would be 0, 0, the width would be 5, and the height would be 6. And then our toString method would output the coordinates, the width, and the height. So let's see how this program would run. I have already compiled this program previously. Okay, so as you see, we have given, it outputs the default values. So let's talk about encapsulation. Encapsulation basically allows for data to be protected in some sort of way. We basically it's impossible for outsiders to make direct changes to these fields, and it is impossible to determine directly from outside the class what values are stored in these individual fields. So if we want to encapsulate data, basically we would have to write private in front of these variables. Keep in mind that there should be a purpose of it. If we write private for all of them, it would be too time consuming to figure out how we can access this data and how we can change the data. So for this class, we are going to encapsulate the width and the height of the rectangle. And here's why. The x-coordinate of the rectangle can be anything. It can be any number from negative infinity to positive infinity. So the domain for that would be XER. The y-coordinate has a similar situation. It could be anything negative infinity to positive infinity. So YER. However, the width has restricted data. It cannot be any negative number, nor could be a number like 0. So we're going to put a restriction of width has to be greater than 0. The height of the rectangle is a similar situation, so height has to be greater than 0. So what's the point? So we will encapsulate our width and height by putting private in front of it. Like that and like that. So how will our program run? Basically like this. If you want to see the individual width, it will say that there is no such field in rectangle that has name width, although we have it here. Same idea for the height. So what's the point of encapsulation? So what is the point of encapsulation if we have no way to see the data or change the data? This is where we have the idea of accessor methods. So accessor methods will allow users to see the value of the instance of that object. So how do we write the definition of an accessor method? Simply like this. So public and then the return type. So double, because we have declared the instance field all double, and then a proper naming convention would have get and then width. And keep in mind, we don't really need parameters because we're not inputting anything into that method. And then we would ask the method to return the implicit object's width. So this dot width. And as you can see, I have written the accessor method for the height as well, with the proper naming convention, get, and then whatever we want to access. So let's compile this program. So now we have to call the accessor method so that we will be able to see the value of that instance of the object. So rectangle r1 dot get width. So it's 5. And then r1 dot get height at 6. Keep in mind these were the default values that were assigned to the default constructor. Now we will write mutator methods for this class. So the purpose of the mutator method is basically to allow users to change the values of the instances. So we will write mutator methods for the width and the mutator method for the height. Mutator method. So you'll write public and void, because it's void because we don't need it to return any value. And then a proper naming convention would be set and then width. and then our parameter would be int width. We need a parameter because the user will be changing the value by using this variable int width. Oh, sorry. It should really be double width since it's a double variable. So, as mentioned earlier, we said the width and height cannot be less than or equal to 0. So, it would be if width is less or equal to 0, system.println try different values. Otherwise, we will change the value of the implicit object's width as requested. So as you could see, I have written a mutator method for the width and for the height with proper naming conventions: set width, set height, and good parameters, width and height. So now let's try the mutator methods and run it with this class. So rectangle R1. Now that we want to change the values of the height and the width, we have to call our mutator methods. So R1 dot set width, and in our parameters we can put any value greater than 0. And R1 dot set height 10.0. So R1. Okay. Now let's try it against the test cases that should not work with the program. That should give out a warning message. Okay, so that works. And that works too. Wonderful. So now keep in mind, we have written these mutator methods and accessor methods for our class, knowing the fact that we have encapsulated our fields width and height. But there is another way for users to give negative values to the width and height, and that is through the constructor with 4 parameters: left, bottom, width, and height. How are users able to change it in different ways? Well, they could change it through our constructor, and through our constructor we have given users total freedom to change it to any value they want. So in our constructor we will write if statements that will prevent users to change it to different values that really should not have the program work. So we will write if width is less than or equal to 0, just a basic message, try different values, else this dot width equals width. So I have written if statements for the width and height, preventing users from changing values through the constructor. Now let's run this program. Okay, let's give it values. Okay, let's give it some negative values. Okay, so it tells us to try different values for width and height. So that is our lesson for encapsulation. Thank you for watching, and bye for now.